Hi, welcome to my demo of HTML5 canvas. Today I'm going to take you through the human walk algorithm. Okay, that is, and I'm going to simulate it in HTML5. So basically, this is the structure of a human leg, only the bone central structure I'm assuming. Okay, our aim is to calculate theta1, theta2, the ankle bottom, and this tricky theta3. Okay, and remember, I'm going to establish that the length of the leg, this part, this to this, and this to this is kept in a percentage variations. Theta1 would be a 45 to 90 degree variations. Remember, this is a browser, it starts from 0 to 0 and increases in this way, okay. So this is a 45 to 90 degree variation, okay. So theta1 would be literally that only, okay. So we calculate this. If I keep this whole angle, okay, so this can be calculated using 90 minus theta1. So this would be this whole angle minus 90 minus theta1 minus theta2. I can get the theta2 bottom to make it a very easy calculation. Okay, that is again 90 minus theta2 calculator will be this angle. So once I get that angle, I'll be done with this point, and this point. Okay. Now, this point. Now I need to calculate this point and this point. So, to calculate this point, coming to focus, okay, would be an extension of this. So it's not much difficult. The idea of creating this is a tricky part. Okay. So considering this as a triangle, it's a thin line drawn. Okay. So I would require this angle. So to determine that beforehand, I need this length, that is from the angle to the tip toe. This is bottom, okay. So to calculate this, I need the length this and this, that is the ankle to bottom, bottom to tip. So square root of this square, a square plus b square is equal to c square. I'll get that. Okay, I'm done. To give q3, that is this angle offset, okay, I have considered a 15 degree offset will always be there. This is based on my calculation. So this is a trigonometric method of implementing it. Okay. Considering looking at the code, let me go quickly. I have assumed you have seen the rest of the demos. Same width, height, frame rate calculations, array, randomness, switch, color variations, frames per second, draw canvas, basic things. Coming back to the focus. I am drawing the canvas, keeping the leg x and leg y at 250 and comma to 50 x and y position, length of the leg of 250. The division of the length of the leg, there is a small explanation here of why I am going to switch that. Use this. Okay. Now, if you come to the thing, I am going to calculate based on percentage of the total length of the leg. I am going to give the length, get the length. Degree to radian is very important. Remember, you need to convert it for sin and cos to work properly in JavaScript. Next, the hip bone variations, theta 0, okay, hip tilt radius is theta 0 for the hip bone variations. Theta 1, as explained in the diagram previously, 45 to 90, theta 2 90 to 180. Theta 2 incrementation would be based on theta 2 limit and min max divided by theta 1 limit min max. It would just won't be 1 or 0, okay. Theta 3 increment would be 90 to 180. Remember, I told you there is a tricky part with an offset. I'll explain this one. I am going to calculate the left leg first of all. Okay, so base left and right, left x and y would be leg x, leg y. Theta 1 would be the max. Theta 2 would be the max. We would start negating from the max, so minus 1. Theta 3 variations are given the base 50 degree offset. Okay, to draw it first, the base of the base knee, I would have a degree to rad conversion. Theta 1 multiplied by length of the thigh is going to give you the knee, okay, the line 2. Theta 2 bottom, if you remember the diagram, theta 2 bottom would be 90 minus theta 2 minus 90 minus theta 1 as calculated before. Again, use the same calculation. Remember, the base won't change for the ankle. That is, this ankle is going to remain to this point only. I have drawn it little offset front to show you how it will be drawn. Okay, and then remember, square root of I initially told you. So I'm calculating this guy's length. Okay, and then ankle angle would be 180 minus. We are not bothered about this 180. I'm bothered about this 180 from this point. So this 180 I can ignore. So 180 minus, okay, the theta 3 limit minimum, 90 is the minimum limit. That is because I have this particular angle has to exceed 90 plus extra. So this is the tricky part of finding out. Okay, plus theta 3 variations of 15 degrees minus the theta 2 angle already calculated on the other side. Okay, so the 15 degree will give me the offset of theta 2b calculations. So this is the tricky part. Again the same calculation for the tip, the side and cos would actually give you the tip toe, that is this part's number. I am going to consider this triangle, so I am actually calculating this angle. That's where the 15 degree offset magic comes to work. Okay, to get this line drawn, remember I have drawn from here to here and here to here. I need to draw this part, right? Remember I have already calculated this point, so we must move to the ankle and draw till the tip toe. And you have done, stroke it. Now the left leg variations theta 1 and theta 3 are done together. I am joining the hip bone and the bottom tap. That is, there will be a tap on the front tip toe. Okay, that is will be combined with the theta 1, theta 2 is separate. Theta 2 variation is I am just changing theta to switch from -1 to plus. So I just need to just keep on incrementing theta 2's length, leg length. LL means leg length. Okay, it just varies from min to max. Theta 1 is the same calculation, min to max, except the theta 3 I told you it's based on the hip bone variation. So when it reaches the max, I'm setting just 15 degrees. Okay, okay, and the theta 3, these angle switch 67, 79 and 57, and that is when you are incrementing. I need a smooth tap. Okay, when the leg becomes straight, I need a smooth tap to happen before I make the leg fully straight. These are the respective angles required for the taps to happen correctly. Okay, and just stroke it. Since I have separated the algorithmic functionality, the left leg and y, left leg and base left leg x and base left leg y has been calculated based on the hip tilt radius. I have not included this to to separate out only the bottom knee portion part. The hip need not bend for a robot, but again, like I am saying, it's a human work, so I have given a sign cos for this also. Okay, so in step 3 what I have done is the same code, but I have drawn a right leg. Again, when this is at max, this starts at min, so the increment is 1. 15 would be the same, and there is a separate code for right leg. It's the same calculations done. Okay, and I would be drawing the hip bone variations for the right leg also separately. So this is the cos side. That's it. And if you see step 3, you can see same trigonometric function actually apply for the tab. If you notice, that's a tab. Thank you for watching this demo of HTML5. This is keys to here. All this code is available in https://sites.google.com/site/keys2. Thank you for watching.